Hi, welcome to the fifth lecture of Ionic Equilibria. Let us start with ionization constant of weak bases, and for that we have to consider an ionization of weak base like BOH in an aqueous solution. Okay, so that BOH, it is a weak base. It undergo ionization to form B plus and OH minus. So these two are the ions and it is unionized base, and there is equilibrium exists between them. Now the equilibrium constant for this reversible reaction is given by Kb is equal to molar concentration of B plus into molar concentration of OH minus. That is, this is the product of molar concentration of products divided by molar concentration of BOH, that is molar concentration of reactant. Now here that Kb, we have to call it as the ionization constant of weak base. So Kb is the ionization constant of weak base and it is characteristic constant and is equal to the product of molar concentration of cation, and hydroxyl ion divided by the molar concentration of undissociated base. So this is the definition of ionization constant of weak base. It is a characteristic constant and it is equal to the product of molar concentration of cation and molar concentration of hydroxyl ion divided by the molar concentration of undissociated base. Okay, now we have to derive the relation between ionization constant of weak base, that is Kb, then degree of ionization alpha, and initial molar concentration C of weak base. Now for that we have to consider ionization of weak base in aqueous solution. Suppose for example ammonium hydroxide NH4OH, it is a weak base, so it undergo ionization to form NH4 plus and OH minus. So this is our equation 1. Now if we consider initial molar concentration, so initially the molar concentration of ammonium hydroxide is C, it is small c. Okay, and initially it is not ionized. Okay, so at that time molar concentration of NH4 plus and OH minus is 0. Why 0? Because our weak base is not ionized. Okay, now it undergo ionization and at equilibrium. So this is second step, we have to consider concentration at equilibrium. So at equilibrium our molecule, our base undergo ionization, alpha is its degree of ionization, and at that time the concentration of NH4 plus is C alpha, and as there is an equilibrium the concentration of OH minus is also C alpha. Okay, now we have to consider the concentration at equilibrium of NH4OH. So that concentration is C into 1 minus alpha. Now why 1 minus alpha? Because the value of degree of ionization can be maximum 1. Okay, and as alpha is the degree of ionization of that cation and anion, so 1 minus alpha is degree of ionization of our undissociated base, and our concentration at equilibrium of that weak base is C into 1 minus alpha. Okay, so these two steps are important. What is the initial molar concentration and what is the concentration at equilibrium? Now the equilibrium constant for this reaction is given by Kb is equal to C product of molar concentrations of products divided by molar concentration of reactant. Okay, now molar concentration of NH4 plus at equilibrium we have its value C alpha. Okay, then the molar concentration of OH minus we have its value at equilibrium which is also C alpha, and the molar concentration of ammonium hydroxide at equilibrium, we have its value C into 1 minus alpha. So we have put that values from this concentration at equilibrium. Okay, so by cancelling the common term which is C, we get final equation Kb is equal to C alpha square divided by 1 minus alpha. So what is our final equation? C alpha square divided by 1 minus alpha. So this equation 2 gives us the relation between ionization constant Kb, then degree of ionization alpha, and initial molar concentration of weak base. Okay, so this is about the ionization constant of weak base and the relation between ionization constant, degree of ionization, and initial molar concentration of weak base. Thank you.